Okay, another clock kit from Banggood, and this one is described as instructions: an LED digital electronic clock suite. I don't know why, but the Chinese call kits sweets. Why, I don't know, but there you go. It's all part of the translation, I'm sure. You can see the instructions there. There's the layout of the board. We've got the component list. And we have the welding instruction steps and matters needing attention, one of which is the LEDs, which are here and are quite large. And you can see you've got a red dot on there. That means that they're red LEDs. One of them has to be installed upside down, which I think is because of the dot there. Probably indicate an alarm is on or off or something like that. The other interesting thing about this one is that instead of having the traditional little piezo buzzers, it's actually got a fully fledged speaker. So I don't know if it makes better and more interesting sounds. I have no idea. Let's have a quick look at the board. Board is nicely manufactured, very clean. Let's see which way is up. Those are where all the components are laid out. Fairly straightforward. Fair few resistors there. We have a couple of chips to put in, well, 3 actually, all socketed. These are the Stc Chips, or Stc main controller chip, I think. And it also comes in a case, again, clear plastic acrylic case, covered in a paper film to protect it until use. Obviously all the necessary hardware to put it together. And you see you've got some holes there, which is obviously where the speaker will eventually be located. And also, usefully, we've got one of these, which is basically a diffuser, if you like, for the LEDs, so which will actually make them look a lot nicer. A lot of the kits, or very few of the kits, actually supply these, and it's a good idea. I'd like to actually find out where I can get this material. I have looked around, but I can't seem to find it anywhere. So if anybody knows of a source, let me know. Let's have a look at the components. Get them all out. So we have the typical battery holder, which will take a CL1220, which I don't think is supplied. Note, and oh yes it is, I tell a lie, there you go. They've supplied a battery, well that's great, that's good. And again, yeah, that's a CL1220. Jack for the power, push to make switch, 2 of those, and some ceramic capacitors. We have a photoelectric cell, which means that it will dim the LEDs when the lights go off. That I think is a thermistor for finding out controlling, not controlling, but monitoring the temperature. We have a crystal. That will be for crystal reference for the clock. And we have a bunch of resistors, and then of course the speaker, which is very thin. But it'll be interesting to see if it makes any better sounds than those horrific beepers that they normally put in, which I've stopped installing when I make these kits because they make such a racket when they go off. So there we go. It's actually fairly straightforward, not a great deal to it. As I say, socketed connections there. So let's crack on. Now the first thing I always do is install the resistors. and all the resistors are unmarked in terms of writing down what their values are, and I'll struggle to read the colour bands. So using a multimeter, what I will do is I shall measure each of the resistors. Let's see if I can bring that up a bit. I don't really have a very good camera setup, as I'm sure you can see. There we go. So we'll put that onto resistance, and we'll try these first, and we'll see what the value of those is. They are 10k. It says cleaning the screen. So yep, 10k. Now I think probably a sensible thing to do would be for me to make a note of what they are. So they're 10k, and then we'll try these. And they are 4.6k. I'm just looking at the instructions just to see what the resistor values that we are supposed to have are. So there'll be 4.7k. 4.7, okay. And then finally this little lot. Let's measure these. That looks like 510 ohms, or 506 ohms. 510 ohms is what they should be, so that's close enough. So 510 ohms. So now we know what the resistors are, and we know that we can populate them mainly in these locations here, all along there. And I don't think there's resistors anywhere else, as far as I can see. So what I shall do is I shall populate all of those resistors. Alright, so that's all the resistors installed. A little bit hickledy-pickledy there, but yep, they're okay. So, what's next? I think probably the next thing to consider is whether or not I want to put the chips in, because they're fiddly and it's probably easier to put those in than muck about with things like the capacitors that surround them. So I think I might just do those next. So we'll open this packet up, which has got all the chips and the LEDs in, and have a quick look at those. As I say, these are all socketed, so at least that's easy. Well, to be honest with you, I do wonder why they bother with the sockets. I've always thought that it would be easier just to solder them straight to the main board, because it's not as if I'm going to bother fixing it if it breaks down, because, well, frankly, where do you source the chips from? And these things are so cheap, you just buy another kit if you really want to replace it. So yeah, I'm not sure why they're socketed, but they are, so there's probably a good reason for it. Oh, I'm struggling to get into this. This is ridiculous. Ugh. Held together with cling film. Okay, so there's one of the sockets there. Frog in me throat at the moment. So we'll get all the ICs out, and the first thing I'll do is I will solder these sockets to the board in preparation for installing the chips. So that's all the sockets installed. Important thing to note is that you'll see on each socket there's a little notch, and that needs to match up with the notch on the silk screen, which you can see quite clearly on that one, and also on the large one here, and also on the other smaller one. And just there. And of course what will happen is that they will match up with the notches on the chips themselves. So that notch there, for example, will match up with the notch on its respective place. Now, why don't you want to focus? Swain. Right. So now that is the NY3P06. And just having a look at the PCB diagram, that one goes in that socket. So let's do that. Now, one of the big problems with these chips is that if you look at them, the legs are somewhat splayed out, and therefore I think this is probably a good way of frying chips if you're not careful, but just give them a bit of a bend. Like that, just to straighten them out a bit so that they can fit in to the socket, like so. Well, I bent those a little bit too far. Difficult doing this on camera. I'll take it off camera if you don't mind. There we go. So there you go. Once you've got it in slightly, then just press it home like that. And again, you've got the notch matching up all the way down. So I'm going to install the other two chips on the same basis. And that's all three chips installed. Just thinking actually about the use of sockets, I think probably one of the reasons is that obviously if the chips are socketed like this, then the actual chip itself doesn't get exposed to heat from a soldering iron, and that may very well be the reason for it. So from that point of view, having a socket isn't a bad idea. Yeah, slightly wonky, but they've all gone in okay. The large ones are quite difficult to bend the pins without actually touching them with your hands, which I mean, I don't know how static sensitive these things are, but yeah, I'd rather not take the risk. Okay, so what's next? Well, we've got a crystal here. So let's pop that in. There's the crystal. That lives just in there. Just splaying the legs a little bit. And the crystal is not polarity sensitive. In other words, it doesn't matter which leg goes into which eel. So we just pop the crystal in there like that, and then bend it down. Just splay the legs a little bit so it doesn't fall out. Right, there's my tiny piece of solder. Let's get another piece of solder out in a second. And we'll solder one of those legs in. Just a tiny amount of solder. You just don't need too much solder at all. So is that going to focus for us? That's all you need. Let's just do the other side. Throw away some of the rubbish. And Is it right? So I'm sorry, I can't talk and solder at the same time. I've mentioned that before, but there you go. Right, and then snip those legs off. Let's have a look at the other components. You don't need to watch me solder all of those in. But there we go, that's the crystal, nicely installed flat against the PCB. We have got the battery holder, and that will be around, I think, that way, like that. And just the two tabs soldered in. Then the switches will go in at the end, like that. There's one. And there's the t'other. Electrolytic capacitors. Now, these are polarity sensitive, which basically means they have a plus and a minus, and you can see the minus is pointing to a short leg. So short leg is minus, long leg is plus, and you have a look at the board, and is it 10 microfarad? Yep. You can see on the board where it is marked with a plus symbol, making the other a minus. So let's do that now, might as well, since we're talking about it. So it will go in long leg into plus, short leg into minus. Let me just pop that down like that. Split the legs out a little. Get myself another bit of solder. And just initially solder one of the legs and heat it up so I can get it nice and flat against the board. Looking okay. I'll do that. And a little blob of solder to the other side. Trim the legs. And that's the electrolytic capacitor installed. Almost straight as well. Good lord. Right, so there's not many components left. We've got a few ceramic capacitors. We've got the photoelectric cell. Again, that's not polarity sensitive, doesn't matter which way it goes around. It's basically a resistor. And we did have a little thermistor. Oops. Which is that tiny chap there. I think it's a thermistor. Yeah, I'm pretty sure it is. And again, not polarity sensitive. And the only other thing will be the power jack, which I think will go in there like that, or something similar. Is that a bit? Oh, I've got around the wrong way. Fill. There we go. And it pokes out the side. So I'm going to get all those components in, and I'll come right back to you. Right, I've got the board completely populated now, including the thermistor and the photoelectric cell, which are slightly protruding from the board. Well, quite a long way with the thermistor, actually. The main reason for that is that normally with these cases, they have holes for them to protrude through, which I think is what these are for, but I haven't quite worked it all out yet. Particularly with the thermistor, so it can not be impacted as much by the heat, if any, given off by the board itself. So it bends down like that, for example, and it can sample the room temperature rather than the temperature of the device. Went a bit wonky on the power jack, but never mind. Wasn't paying attention when I did that. And I think everything else is pretty much done except for the speaker. So that'll be the next job. I'm not too sure what the orientation of that will be, so or whether it actually even matters. Possibly doesn't matter, but we'll have a look. Right, well, the build is finished. I've got the LEDs on, got the speaker on. Not sure if the polarity on the speaker is an issue or not, but yeah, not 100% sure about that. But at any rate, yeah, she's finished. So I think what we need to do is our initial test, and to plug it in, give it some power. Okay, no sound, but we have a flashing. Let's turn the lights off. 000. Although I'm noting that that LED there wasn't lit. I reckon it should be. So that might be an issue. So what I'm going to do is I'm going to investigate that and see if we can't bring some life back into it. That's working. I think that's the day. That's well, I assume that's the temperature. 1 Celsius. No, it's a bit warmer than that. And that's the time, which makes sense that it starts at 0. But that LED is not lit, so I might have screwed up somewhere on the soldering. Let's have a look. Right, well, I've got it going, and I fixed a slightly dodgy solder joint, so the display's working fine, and the speaker's working, and it's already making very annoying sounds. So let's see if I can stop it doing that. How do I stop it? I don't know. And it's doing my head in. Right, there's one or two things I can do. I can look at the instructions or chuck it through a window. I'm favouring the window at the moment. I'll get back. Right, well, I have fixed it. And actually, I'm an idiot. And the reason I'm an idiot is I forgot to install that switch there. Now, these kits are often so just supplied with 2 switches that I didn't realise there was a third one which should go in there. So that was a bit of a struggle to solder that, because I'd put the LEDs in. I couldn't get underneath so easily to solder that switch in. At any rate, I needed to press that to stop the sound going. So let's turn the lights off so you can see that. Now I've actually got the light on the camera is washing it out a bit, but there you go. But you can see it's all lit up, so it's working. Next thing to do, I think, is to install the case. Right, well, I've had some fun and games with this clock because I made a bit of a mess of it. And the reason is that I forgot to put switch 1 on, or let's get some light on this. I forgot to solder in switch 1. And because I'd already installed the LEDs, getting switch 1 in was a little bit tricky, trying to get the soldering iron in there. And you can see I eventually cut off these legs so I could get in there. But in doing so, what I managed to do was bridge the contact points, which are there and there. They got bridged to the casing of the switch, which I didn't realise. So what I've had to do is just bend out those 2 tabs there to break that bridge, and all is now well. And I've gone through the Chinglish instructions, which are very difficult to understand, but one of the things that you have to do is to hold the 2 buttons in, which is switch 3 and switch 2, switch 3 and switch 2. Let's zoom out again. So you hold those both in and then plug the power in, hold it for about 10 seconds, let go of the switches, and it will come up with the time as 7:59, and then you can follow the instructions through on how to set it up, and everything's worked absolutely perfectly. So I'm pleased about that. So what I'm going to do now is get the case back together. One thing I didn't realise is that the case is actually black. You can see I've started to build that bit, and the front is clear plastic. So you can obviously see the clock, and also there's a space for the speaker, but there's no way of actually sticking the speaker down. So you can see here I've just used some electrical tape, which I'll use to hold it down for now until I can think of something better. Anyway, what I'm going to do now is I'm going to build up the clock case, and also install this plastic diffuser, which goes over the display like that, and it doesn't look great on camera, but that makes the definition of the LEDs much easier to read, so that's a good thing. So let me put the case together, and I'll show you the finished article. And here it is, complete. As you can see, the rear of the case and the sides are black, and obviously the front of the case is clear. And because of this speaker, normally you just have the power cable going straight into the side, but obviously the speaker has widened the case, and therefore they've got this cutout arrangement so that you can get to the power jack. That cable is not the cable that came with it. The cable that comes with it has got a right angle on it. I won't go into the reasons why I'm not using that one. I'm using it for something else at the moment, but it's got a right angle, so this one's a bit tightly stuck in there, but you'll get a right angle one which will fit in there much more neatly. Yeah, so it's fine. The obvious difference with this one is the speaker, and you heard it make a racket before. The extra button on the top, which is switch 1, if you press that, it will talk to you thusly.
It is 19 past 19.
Now that was, it's 19 past 19. Yeah, it's a bit of a difficult translation, I think, or accent to listen to. Let's try it with 20.
It is 20 past 19.
Yeah, not bad. Again, when you consider the cost of these things, which is extremely low, then, you know, I'm pretty happy. I quite like this clock. I think it's a bit different with the speaker, and the fact that it talks just about is interesting. And it was quite enjoyable to make, despite the fact that I did mess up on a couple of things, but I managed to fix them. So there we go. That's what's the actual title for it? I don't know if it has got a title. LED Digital Clock Electronic Clock Suite Phonetic Version YD-030. So there you go. That's I'll put all of that information in the description to this video at any rate. So yeah, quite enjoyed making this one, and it's gone together quite well. Just that a little bit different from the normal electronic clocks you get from Banggood and the likes. Oh right, so there you go, finished. Hope you enjoyed it. I've got some more kits that have come in, which I will be looking at very shortly. There's one of them there, all sorts of clever stuff. So yeah, more videos on the way, and some test equipment as well, which hopefully I can learn a bit more about electronics properly. Putting them together and soldering them together is all well and good, but I want to learn a bit more. So again, more videos on that. In the meantime, thanks very much for watching. Hope you enjoyed it. Catch you again.